Here is the next example. We are doing the mesh analysis. Sometimes we need to solve the circuit by using super mesh analysis. So this example is basically a super mesh analysis circuit. But in the exam, most probably I will not ask for super mesh, or I will not indicate that it is a super mesh. You have to find out whether it is a regular mesh analysis or super mesh analysis. Now, so step one, find the meshes in the circuit and assign the mesh currents. So you can call it as mesh or loop. Mesh is the shortest loop anyway. Okay, I'm having two meshes here, so I1 and I2. So there are two meshes, I1 and I2. So next step is applying KVL. Okay, so step two, apply KVL. But before applying KVL in each loop, you need to check these two. Okay, so first one, check if there is a current source at the outer branch of the loop. If there is a current source at the outer branch of the loop, so instead of this is a current source instead of voltage source, then you don't need to apply KVL in this loop. I can take that loop current as that branch current. By the way, these are all the outer branches. Okay, I don't see any current source in these outer branches, so we don't need to worry about that part. Second one, check if there is a current source between two meshes, then solve it by using super mesh analysis. Do we have a current source between two meshes? Yes, I have a current source between two meshes. So I have to solve it by using super mesh analysis. Okay, in super mesh, make sure you will have two equations when you're writing the super mesh. There might be more than two equations in the whole example or whole problem, but when it comes to the super loop or super mesh equations, you will end up with two equations. One is a very big equation, another one is a small equation. Okay, so here I can clearly see there is a current source between two loops, so I'm going to do the super loop equation. So super loop is nothing but whenever you see the current source, wherever you see the current source, leave that current source, okay, and walk around those two loops, okay, or two meshes. So it's going to be loop 1 and 2, apply KCL. So before applying KCL, make sure you assign positive and negative signs according to the current direction. So according to my I1 direction, this is plus minus, this is plus minus. According to my I2 direction, plus minus, plus minus. Okay, I2 direction, this is going to be plus here, minus there. But anyway, the 6 ohms doesn't matter for us anyway here. So loop 1 and 2, so I'm going to start there. 2I1 plus 4I2 plus 8I2 minus 20 equal to 0. So if you're entering positive terminal, take that as positive. If you're entering negative terminal, take that as negative. Okay, so here I end up with 2I1 plus 12I2 equal to 20. This is my first equation. Okay, the second equation, this is super loop, so you will end up with the second equation at the super loop. So here is my second equation. Here you are saying there is a 2 ampere source and we're assuming this is I1, I2. So can I write this as I2 minus I1 equal to 2 ampere? This is my second equation. So here I have two equations, two unknowns. Let me write down two equations. 2I1 plus 12I2 equal to 20. 2I1 plus 12I2 equal to 20. I2 minus I1 equal to 2. So minus I1 plus I2 equal to 2. Okay, I'm going to multiply the second equation with 2. So minus 2I1 plus 2I2 equal to 4. 2I1 plus 12I2 equal to 20. I'm going to add these two. This is my first equation, this is my second equation, but I'm multiplying second equation with 2. So when I add these two, I will end up with 14 I2 equal to 24, I2 equal to 24 divided by 14. So the second equation I'm multiplying with 2 to make it to eliminate I1 in the first and second equation. So I added first and second equations, end up finding I2 equal to 1.714 amperes. Our goal is finding Ix, so Ix is nothing but I2, which is 1.714 amperes. But I substituted I2 value in equation 1 or equation 2, sorry, this is equation 2. End up finding I1 value. Okay, so I1 is minus 0.2857. That indicates that I assumed I1 is flowing in this direction, but in reality current is flowing into this source. So the current going in there is 0.28 amperes. How come that is taking current? That's look like a source. How come that's taking current? Because that's taking current because it is charging. It is probably that's a battery which is recharging at this point. Okay, I will stop this video here. I will make more videos, post more examples in the next videos. Thank you.